something unexpected just happened in space. On November the 5th, 2025, as the interstellar object known as 3IAtlas swept past the Sun, it did something that no model predicted. Its light didn't rise, it detonated. An explosive brightening that left astronomers stunned and for a brief moment silent. They'd been waiting for a routine show. What they got instead was a mystery that could rewrite what we know about objects born beyond our Sun. 3IAtlas is only the third confirmed interstellar visitor ever detected. Oumuamua in 2017, 2I Borisov in 2019, and now this. An ancient fragment of another star's nursery, racing through our system at more than 130,000 miles per hour. It has no connection to the planets, no gravitational leash to the Sun, a true stranger. When such an object passes close to our star, its perihelion, scientists expect simple physics. Sunlight heats the ice, gas escapes, the comet brightens, then fades. But Atlas refused to behave. In late October, telescopes from the Lulin Observatory and the US Naval Research Laboratory watched its brightness curve spike, doubling its rate of increase in just hours. There was no warning. One scientist described it as watching a campfire suddenly become a supernova. For an object that had drifted untouched for billions of years, that reaction made no sense. Spectrometers caught something stranger still. The comet's light turned bluer than the Sun. That shift revealed strong signatures of carbon molecules, C2 and amidogen, NH2, chemical fingerprints of ices boiling violently into gas. Radio readings showed that 2 weeks before perihelion, 3IAtlas was losing roughly 5.7 kankeen, 10 to our 28 water molecules per second, 40 times more than a month earlier. That's not a comet venting, that's a geyser in space. SOHO, Stereo A and Ghost 19, each armed with coronagraphs to study the Sun's neighbourhood, photographed Atlas at peak activity. Instead of the graceful dust tail every comet carries, they saw a faint elongated smear, glowing gas with no dust. It was as if the tail had been erased. Some researchers proposed that carbon dioxide gas had been leaking earlier, creating a temporary cooling jacket around the core. That shield suppressed water sublimation until the moment it collapsed, exposing fresh ice to sunlight and triggering the flare. It fits the data, mostly. But others suspect something deeper is at work. After all, 3IAtlas didn't form here. Its chemistry was forged around a different star. The James Webb Space Telescope had already been watching. Using its near-infrared spectrograph, Webb found that cosmic rays, high-energy particles racing through interstellar space, have been striking Atlas for billions of years, transforming its surface layer into a dense irradiated shell 50 to 60 feet deep. That means what we see today isn't its birth material. It's the scorched skin of its journey. As one scientist put it, 3IAtlas is a product of its voyage, not its origin. So the question becomes, what lies beneath that armour? A team in Germany has suggested that interstellar objects like this might be the missing seeds of planets. Captured by young stars, they could act as ready-made nuclei for worlds to form around, a theory that bridges a long-standing gap in planetary science, how to jump from meter-sized rocks to full planets. If true, objects like 3IAtlas aren't just wanderers, they're builders that never found a home. Atlas's path is almost perfectly flat and straight, unlike the looping curves of native comets perturbed by planets. It's as if a cosmic arrow has cut through our solar system once and kept going. Calculations suggest it may be 7 to 12 billion years old, older than Earth, older even than our Sun. It was already ancient when life on Earth was still a dream in warm, primordial seas. What has it seen in that time? What systems did it pass? What stars has it outlived? Professor Avi Loeb of Harvard has formally asked NASA to release every byte of data collected on 3IAtlas. His reason is simple. With so few interstellar samples, the entire scientific community needs to look together. He was also the voice who insisted that Oumuamua's odd acceleration should not be ignored. Transparency, he argues, is how we separate unusual data from imagination. Right now, 3 possibilities compete. First, a natural but highly irradiated comet whose surface chemistry caused a runaway outburst. Second, an object with internal ices layered so precisely that heating triggered a cascade of activity. a natural threshold effect we haven't modelled yet, and third, the one no one likes to say aloud, that the activation was not accidental at all, not proof of engineering but a pattern too precise to dismiss without testing. Science must stay agnostic. We test. We don't decide by comfort. If Atlas is ordinary, its brightness will decline smoothly as it recedes from the Sun. If it's not, we might see secondary bursts unlinked to solar distance, radio patterns repeating with clock-like precision, or motions that defy outgassing models. Over the coming weeks and months, dozens of observatories, or including the Mars rovers watching from another angle, will hunt for those clues. 3 visitors. 3 surprises. Oumuamua accelerated without jets. Borisov carried chemistry no solar comet had. And 3IAtlas exploded without a tail. Maybe they're all natural. Maybe nature is simply more creative than we imagined. Or maybe the galaxy is filled with messengers of a kind we're only beginning to notice. For now, 3IAtlas drifts away, fading into the black, its secrets locked behind a radiation-forged shell. We have one chance to listen before it's gone. Because in the end, every object that crosses our sky is a message from somewhere else. And the real question is, will we learn to hear what the universe is trying to say?